Hello, this is Kai. I'm a professor at Middlesex University in London. My work mostly involves analyzing data using both computation and visualization. Today, I'm going to explain to you what is visual analytics and how that can be used to address the many challenges we have in making sense of big data. I'll explain a little bit later why the big is in bracket. This is my webpage. You can find information about my work there. I also have a GitHub page, which has the tools developed in my work. Here is the outline for the presentation. I'll start by explaining what is sensemaking, and then why do we need visual analytics to address the challenges we face in sensemaking. This is followed by two demos. The first one is a sense-making tool called SAVI, which is used to analyze social media data. The second tool is called SenseMap, which is designed for online sense-making. Okay, so what is sense-making? It just means making sense of data. It includes collecting, understanding, analyzing, reasoning, and finally making decisions based on data. When people say data analysis, they usually focus on the analyzing stage of the sense making. It is something we do every day, more than you think. For example, planning a holiday, buying a house, or understanding an illness are all examples of sense making. Take planning a holiday as the example. You need to collect information about the flights, about the hotel, about destinations. And if some place you've never been to, you need to understand what are the interesting things there. And then you have to compare different places, different flight and hotel options, and come up with a completely package and make the final decisions. And sense making also happens in more serious contexts, and for example, defense, policing, investment, and medical diagnosis. For example, investing a crime is a typical example of sense making in the policing domain. In academia, doing scientific research is another sense making task we almost do every day. So how is it different from data analysis? While the goal of sense-making usually is quite clear, how to get there is often not. So this often makes the sense-making process exploratory and takes a long time. Using maze as an analogy, the goal is the center of the maze, it's quite clear, but how do we get there is not so clear, at least from the beginning. So to get there, you need to take a long time to explore the maze before you can eventually find a way to the center. Okay, let's see a more concrete example. My wife and I decided to buy a new camera for our newborn baby. So I have a budget of £500. So the sense-making task is to find the best cameras, cost about £500. How would you do this? I'll give you a few seconds to think about it. Okay, this is how I will do it. So this is our goal, to find the best camera for about £500. While you can Google it, it might not give you the answers that you want. So one thing I want to do is I want to maybe find out what expert says. This would be involves reading many online reviews, looking at different recommendations. You might ask your friends who knows better about camera than you. What are their recommendations? During this process, you will come across many different models, something like these. Something you might heard of, but something you might heard for the first time ever. And also you will starting come across these different attributes or things they use to describe cameras. For example, pixel number, which is relatively easy. Image quality, something quite straightforward but much harder to measure. And then sensor size and camera lens, which are more obscure aspects of the camera. And finally, things like form factors, which essentially just means the size of camera. And you have small, which is like smartphone, and then compact, micro four thirds, or even full frame. So at this stage, you might claim many different terms you're not familiar with, and you need to do a different branch of research just to understand what it is before you're coming back. And this could happen at any steps of the process of the sense making. For example, for image qualities, you might come across terms like noise reduction, and for camera lens, you know there's something called aperture, and there's some more obscure terms like chromatic aberration. So each of them will probably require a separate branch of research just to understand before you can proceed. After you understand all these terms, you seem to check the price for all these different models, and finally to compare them before you can make a decision. This process is usually going to take a long time, and this is what it looks like after an hour. In case you didn't notice, the focus is the many tabs you opened in the browser. Okay, this is a common challenge we face in sense making, and it is much more than just a tab organization challenge. So the questions we have is, how do we know which one of these is relevant and which is not? Where the information about chromatic aberration that I saw, say, 5 minutes ago? Okay, and what are the factors important to image quality? This is something you would understand as you go through the sense making. And how to compare different models. Currently, this is obviously not the most efficient way to do that. Because these sessions are usually quite long, you can't finish in one go. And if you have to restart after a few days or even a week, and it could take a long time to get your mental into the same state as you finish at the end of last session. And finally, after you spend weeks or even months to find the best model possible, and you have to convince others that is the best model. And how do you do that? This does not just happen in browser. It could happen on your desktop with many of documents, files, and tools opened during the process of sense making. And it could also happen in the physical world with lots of books, reports, files, and printouts. So someone did a nice job on this, analyzing different sense-making tasks and abstract out the essential steps in a sense-making process. And this is called Sensemaking Model. In this particular model, you start from the bottom left corner, which says external resources. And the actions involved in this step is mostly about search and filter. This is like conducting Google search and find what is relevant. After that, you put all the information you found relevant in the so-called shoebox, which is the next box further up and to the right. And the sense-making actions involved here would be read and extract. So you actually go through the things you found relevant and extract useful informations. And this becomes the evidence file, which is the yellow box in the middle. After that is the schematize, which is numbered 8 in the model. And this is the part where you form a mental model of the tasks or things you need to analyze or making sense of. In the digital camera example, this is where you start to understand what different terms means. For example, what is the aperture of a lens, or what is the noise reduction level of a image quality, and how this will impact what you want to do. Say, for example, how the aperture of the camera lens affects the image quality of the camera, and how that in turn also affects the price of a camera. Once you have understanding of the camera, or build the so-called schema of digital camera, you can start to build your cases. Essentially, say, forming some hypotheses about different possible candidates to consider or compare. And then once you've done that, you can make a conclusion, which should be quite easy at that stage. And more importantly, you can tell a story of why that is your decision, which leads to the presentation. Okay, there are two more things I want to point out. There are many loops in the model. For example, there's a small loop starting from step 1 all the way to step 7 and go back. Okay, and then there's larger loops starting from the bottom left all the way to top right and then go back. These loops are there to indicating the sense making is rarely a linear process. You go backwards and forwards all the time, and this is also part of the results of its exploratory nature. The other thing I want to point out is the axis in this model. So the x-axis represents amount of effort required. So I start from the external resource, which involves search and filter, which require fairly little effort, to the actions on the right, such as forming hypotheses, doing presentation. It requires much more effort. And the y-axis represents the structure of the result of sense making. At the beginning, there's very little structure. For example, the search result is only marked either relevant or not relevant. At the end, when you're making a presentation, it's a very structured story-like or narrative you created from all the information you gathered during the sense-making process. Okay, let's again using the digital camera as an example. So the external resources, including all the information about cameras. And after search and filter, and you have the information about the camera but relevant to my particular need. After read and extract, you're starting to understand these concepts or terms related to digital photography or camera, which is relevant to you. And this helps you to form a mental model or an understanding of how camera works and how these affect its, say, price, image quality, etc., etc. And then you, based on this knowledge, you can pick a few candidate models and make a comparison and eventually make a decision which one you want to go for. And finally, you need to present all the conclusions and the process to someone else, and this is your presentation. Okay. So this works the same if we want to analyze or make sense of big data. So all these steps will be involved. Currently, there's lots of technology that's available to store data, a lot of them, so some of these are listed here, allow you to search them very quickly. So the technology provides these major search engines. And this tools allows you to analyze them relatively quickly, doing statistical analysis. These are some examples, but I would argue, say, there is these are all focused on the bottom left corner of the model, and there's relative much less tools or effort to develop tools for the rest of sense-making process, which are equally important, if not more. Currently, deep learning is very popular, partly because AlphaGo, which beats the best human Go player recently. However, I would like to argue that AlphaGo probably will not be able to solve the sense-making challenges alone. While the Go game is very complex and difficult, its rules are very well defined and the results are easily measurable, whereas these are not the case. For the camera example, there's no clear rules. You can almost do anything in your power, and the progress are much less clear or measurable. And also, from a practical point of view, not that many people would have the knowledge and resource needed to build a deep neural network, collect all the required training data, and run and tune the model just to find a camera they want. Okay, what is the solution then? Before I answer that, I have a question. Who is the best chess player in the world? We all know in 1997, the algorithm Deep Blue beat the best human chess player at that time, and this is a picture of that. However, currently, the best chess player in the world is probably a human-machine team, and the two people on the team are not even professional chess players. Working with an algorithm, the team can beat best human player and best chess algorithms. Why is that? Because this team integrates the complementary strengths of human and machine, and I think that is the way forward. Human brain is actually a very powerful computer. It is not designed to do calculations or remember everything, but rather it is very good at doing pattern discovery and recognition, even better than the fastest computer we have in the world. The best way to let human interact with data is through visualization, because that is the fastest channels for human to perceive data. So this is a picture from Facebook showing the connections between their users. So each dot is a user, and two users are connected if they are friends. Okay, so what can you see from this visualization? There are things quite obvious. For example, there are lots of users in North America, lots of users in Europe. And also there's lots of connections between these two as well. You can almost see the contour of different continents as well. These are kind of expected, but you can see very quickly from the visualization. However, is there anything odd about this picture? I'll give you a few seconds. Okay, some of you would have figured it by now. So while most continents are shown on the map, there's larger land mass missing in the top right corner, which are actually the Russian and China. The reason being that Facebook is banned in both these countries. As a result, they are missing from the map. The point here being, an insight like this, human can pick up very quickly in a few seconds using their common sense and knowledge. Whereas for computers, this is much harder. To processing all the data will take long time with millions or even billions of records. And this is some insight related to what is not in the data rather than what is in it, which is almost impossible for the computer to discover. So this is an example of what data visualization can do. First, confirm the expected to make sure data are roughly corrected as you expected, but also discover the unexpected, reveal some new patterns or anomalies in the data, which actually usually leads to interesting findings. So this leads to visual analytics, which essentially try to integrate human and artificial intelligence. So human is always in the center. This integration, when done through visualization, will be becoming the interface between human and data. So these data will be analyzed using algorithms like deep neural work and other artificial intelligence techniques. And then, for human to be involved in this analysis process, it needs to be done through interaction. There are already many work done between these different fields in computer science. There's lots of work to develop interactive visualization techniques to make it easy for user to analyze large amounts of data visually. And there's studies from, for example, human-computer interaction, cognitive psychology, and perception to make sure the visualization is designed the way we as human to see the data. And also there's methods or techniques that combines visualization with algorithms to make this happen. And when you integrate all three together, you have visual analytics. I'm really excited about this new paradigm called visual analytics, and I believe it will be the way to solve lots of challenges we're facing now, particularly in big data. Here are some of the works I did in the last 5 years. So obviously, there's no time to go through all of them in this presentation, so I picked the 2 examples. And the first one is called SAVI, stands for Social Analytics Visualization. It is a visual analytics tool designed for social media analysis. It is initially designed for VAST Challenge, which stands for IEEE Visual Analytics Science and Technology Challenge. The challenge provides you data and analysis tasks. You need to design and implement visual analytics tools to answer those analysis tasks. This challenge is participated by leading research groups around the world and companies doing data analysis. This example is from 2004, mini challenge 3. So the data you have is tweets. We'll see example in the next slides. And the tasks is to detect and describe crime using the tweet data only. If you think that for a minute, it's actually a quite difficult challenge. No criminal will describe their activities in tweet. Say, I'm going to rob this bank now. So to detect and describe a crime using tweet only is a quite subtle and delicate task. There is a quite elaborate setting and context of the crime, but we will not have time to describe now. So let's go to the data. So this is a sample of the data you were given. Essentially, this is tweets just as we have it. It has the authors, the person who created the message, when it's posted, and the message itself. The last column is the location, and only a small percentage of the tweets has locations very similar to the real-world situation. The first challenge is to find the starting point. And to do that, you need to know what's in the data. Given there are so many tweets, by just reading through them is probably not the best way forward. And here is where the visual analytics tools come in. So the tool, which is called SAVI, is short for Social Analytics Visualization. It is not designed to providing the answers to tell the user what the crime is. That's the analyst's task. What it does is to give you an overview of the data, showing any patterns visually, so give the user some clues where to start their investigation. This is the interface of the timeline tools of SAVI. So start at the bottom, it is a timeline or histogram, which shows the number of tweets over the time. So you can easily see there are two peaks, one at about 6:45 and another one about 7:45. So user can select on the timeline or the histogram to show all the tweets within that period. And on the right hand side column is the result of something called named entity extraction. Essentially, this is a natural language processing algorithms goes through the text and pick up all the entities it can recognize. These including persons. So you can see there's Silva, Marek, Lucio, Jacob, etc. Different organizations, different facilities, and different cities. The main part of the visualization is the timeline. So if you pick any entities from the right columns, for example, the Abila Police Department, which is shown in orange, all the tweets containing that entity or term will be shown on the timeline and with orange as the color background. So these are the bottom part of the timeline. So each line is a tweet, the dot at the beginning indicating the time when that message is posted, and the color of dot indicates sentiment. So the red ones are the negative sentiment, the white ones are neutral, and the green ones are positive. And you can see there's lots of messages from the Abila Police Department. And similarly, you can pick other entities. For example, the most common facilities in the dataset is called the dancing dolphin. And this is selected and shown with the blue background. And finally, another one selected is the term Abila, which has the green background. Any messages contains both topics will be shown as the overlap sections of the two topics or two entities. As mentioned before, the tool itself does not give you answers, but just give you some clues to review the patterns in the data. For example, if you look at the histogram at the bottom, it tells you there's a peak, so maybe there's something to look into. And again, if you look at the entity list on the right, you will see something like dancing dolphin, which is not very obvious what that means, but appeared lots of times. Again, another clue, maybe something to further look into. And the tool itself is interactive, as we'll see in the video on the next slide, and allows you to quickly discover and examine many of these potentially interesting facts from the data.
This is the timeline view. At the bottom, a histogram shows the distribution of messages over time. We can see that there's a peak at about 6:45. If we select this peak, we'll see the messages sent during this period. Each of these is a message. On the right, you can see a list of entities that have been identified in the text of the messages in the dataset. So for dancing dolphin, we can see that there are 33 messages in the current selection containing that entity. We can click on the entity to see only those messages containing dancing dolphin. There are still quite a few displayed, and we notice that many of them are retweets. We can filter out the retweets by unselecting the RT option. This gives us a much smaller set to work with, and we can zoom out on the timeline to see all the messages telling us about the fire at the Dancing Dolphin apartments. This looks like an interesting event for further investigation. To help do this, I'll create a new event entity called Fire2, and it'll appear in the list over here. I think this message might be important, so I'll add it to the new event Fire2. This way we can collect together all the messages we think are relevant to a particular event. And here I'm showing you a pre-collected event that contains messages that we found relevant to the fire.
SAVI has other visualizations besides the timeline, so these are the map visualization and sensemaking support. The map visualization plot all the messages with locations onto the map so you can see where they were posted and potentially any patterns in those messages. The sensemaking support allows user to record findings. Each box is a finding, the picture shows the data, and the text describes what the finding is. User can group these findings and based on if they are related to the same person or particular location, or they can link them as shown here. For example, there are a few findings about the sighting of the same vehicle over time. So I will not show you the details of the data, but this is the final findings or the answer to the challenge. There's a company called Gas Tech International, and a kidnap happened there. And there's also a fire in the city, and the apartment on fire is actually called Blue Dolphin, we seen a little bit early on. This building happens to be close where the hostage was captured, so the criminals have to move them in a black van. The van runs erratically through the city, and wrong traffic lights hit the cars and cyclists along the way and being spotted by the people in the city. Eventually, the van was stopped by the police and there was a fighting at the ice cream shop. There's still a long time before artificial intelligence can do such inference fully automatically, if ever. And also, this is very difficult for human too. Without visual analytics tools, it will take much longer to find out the answer, if possible. As mentioned before, and the tool itself does not provide answers but rather than leads. Human is in control, and the tool is there to support human sense making, make it more efficient and effective by revealing patterns or any anomaly in the data so the human users can spot them more quickly. So going back to this previous diagram, the tools developed here providing some support to the rest of the sense-making process. So this is the end for our first demo of the SAVI tools. If you're interested, you can find out more from the GitHub page mentioned a little bit early. Now we move on to the second tool, which tries to build a map of sensemaking. As mentioned before, sensemaking is kind of like exploring a maze, where you know where you want to get to, but don't know how. So in such situation, it will be quite useful if you have something like this. So this is kind of like a mini map from a game. At the beginning, everything is covered, but as you explore the map, more and more it will be reviewed, so you can see different passes and how they are connected. Once you have a map like this for the maze, it will be quite trivial to find the way to the center. SenseMap follows a similar idea, but instead of building a map for a maze, it tries to build a map for your sense-making processes. So this is what the tool looks like. It provides some browser enhancements, which allows you to, say, highlight and annotate text on a particular page. It also has something called History Map, which records all the different pages you visited, how these pages relate to each other, and the information you highlighted, including text and images. And finally, there's a knowledge map, which allows you to group and connect things you find in any way you want. Next, we'll see a video of SenseMap using the 500-pound camera as an example.
Let's consider finding a camera for taking photos of babies for less than £500. This is a Chrome with SenseMap enabled. The history map displays the provenance of sense-mapping actions alongside the standard browser window. Let's start by searching for camera baby photos. This search is captured and shown in the history map. The magnifier icon indicates the actions and the text shows the keyword. Back to the browser, let's open some links as new tabs. In the history map, these tabs are shown as branches coming from the same search results page, where dotted borders indicate they haven't been read. Let's click on this bar to open this page and highlight the information that seems important, such as good camera should have a fast autofocus. Or the price of a camera, and take a note about it. Let's set the camera image to represent this page in the history map. Highlights are shown inside the page, allowing them to be revisited directly to where they occurred. Similarly, this process is repeated for the second camera. Let's move to the next search result page. This page discusses taking photos rather than reviewing cameras. To avoid distractions, let's minimize this page. A novice may wish to learn the basics of a camera before making an informed decision. This page shows a few types of cameras with the pros and cons.
Okay, so here's a comparison. Without SenseMap, this is what you get. A browser window with a few tabs. And it will get much worse when you have lots more tabs. This is SenseMap, and still showing the same amount of tabs, but it shows the relationships, and they are grouped by their connections and similarities. And also the important text and images are clearly shown, and you don't have to go back to the particular tabs to find them. Okay, so this is certainly just a starting point for sense-making research. So in the SenseMap, mostly the features only supporting the lower stage of the sense-making. If we go back to this model, we can see the SenseMap tools allows for shoeboxing and collection of evidence files. It allows you to identify the relevant information during the sense-making process and easily get back to them. But what is not supported yet is the schematized, the hypothesis, and presenting the presentation stages, which is lots more work to do. Also useful here is further integration with machine learning algorithms. So far, there's little of it in the SenseMap. What we can do with machine learning algorithm is actually to use the data from SenseMap to better understanding what user want to achieve. For example, if the algorithm understands user is trying to buy a digital camera and comparing different models, it might be able to providing better support. Another very interesting thing I would like to explore is to providing a coverage map for data and possible solution space. For example, in SenseMap, if you know you want to compare 5 different models and you want to see, okay, I have compared 3 models so far and I still need to collect information of 2 other models to add them to the comparison. And for each model, is any particular information still missing? Go back to this mini-map analogy. So currently, the SenseMap only shows the visible part, but we want to know what the whole area is look like and what are the parts which hasn't been quite revealed. Okay, this is the last slide. So some summaries and takeaway messages. So sense-making is about how people understand, reason, and make decisions using data. So it's a more broader concept than data analysis. And it is important to big data, and there's very limited support currently available. So visual analytics combines data visualization with analytics. Essentially, it combines human intelligence with machine intelligence, and it's a promising approach to providing support for many of the challenges we face in sense making. And if you want to find more details, here is the link again to the GitHub page, which has information of the 2 tools presented in the talk. Okay, thank you. Bye.